basic properties of logarithms using the fact that logarithms and exponents are closely related to each other. The properties of exponents can translate nicely into properties of logarithms. Right? The product rule of exponents says that if you're multiplying like bases, it turns into addition in the exponents, or if you're adding in the exponents, it turns into multiplying in the bases. And working with that the same way in the logarithm, adding in what would be the result is the same thing as multiplying inside the argument. So log base b of m times n is the log of m. I ran out of room there, sorry about that. Log of m plus the log of n. So if I have something like the log base 4 of 16x, I can split this up and separately consider the log of 16 plus the log of x. And since 16 is 4 squared, the log base 4 of 16 is 2. So we can simplify expressions using this property. We also have a quotient rule of exponents. Subtracting in the exponents, dividing in the bases. Generally, you learned it as when you have division in the base, you turn it into subtraction in the exponent. Again, things happening to the base are things happening inside the argument of a logarithm, and things happening in the exponent are things happening to the result after you take a logarithm. So the log base b of m divided by n is going to be the log base b of m minus the log base b of n. Here we can start getting into some more interesting examples. If I have the log base 5 of 75x minus the log base 5 of 3x, then using the quotient rule, this is the log base 5 of 75x over 3x, and that's a fraction we can reduce, turning that into the log base 5 of 25. And 25 is 5 squared, so the log base 5 of 25 is 5. Finally, using the power rule, exponents on your base turns into multiplication in the exponent. and exponents inside of the argument of a logarithm turn into multiplication outside the argument of a logarithm. So we can use this to simplify expressions that have a variable hiding along inside it. In fact, this is the property I've been using. To simplify the arguments that we've had before. Every now and then, this property does come out to be useful in evaluating a logarithm. For example, if we have 3 times the log base 8 of 4, well, that's the same thing as the log base 8 of 4 cubed, and 4 cubed is 64, which is 8 squared, so 3 times the log base 8 of 4 comes out exactly as 2. This last property is also incredibly useful in working with equations, something we'll get to a little bit later. If we have an exponential function, log base 10 of 7 raised to the x power, this is x times the log of 7. And while the log of 7 does not come out exactly as a decimal result, this still went from being an exponential to being a linear expression, because even though I can't evaluate this analytically, log base 10 of 7 is a constant value, and I can work with it as part of a solution.